Hi guys, this is Vladimir from Mobatec. Welcome to a video help of the second exercise of Mobatec Modeler Introduction course. Before watching this video, I recommend you to read the entire text of the exercise so that you are able to follow this video successfully. Let's start with the exercise. The name of the exercise is Simulation of a Closed Circulating Flow Loop. And by the end of this exercise, you will know how to build a flow sheet from the library unit models, how to input parameter values, initial variable values, and initialize the systems, how to add variable displays, and how to run a real-time dynamic simulation in Mobatec Modeler. So this exercise is intended for the beginner users to learn how to use library models as a building blocks to build their own process models. The section 1.3 model description. A model description is given. Here we have a P and ID of the process, and if we scroll down a bit, you will see how this model looks like in Mobatec Modeler environment. As we can see, we have two atmospheric tanks and a third tank which is pressurized with gas. We have a pump, we have one source and one sink, and we have a heat source with the on-off button. We have a lot of pipe joints and a lot of recycle bypass lines. So let's start with the actual exercise. In the chapter 2 called Things to Do, we have defined all the tasks that you should perform to finish the exercise. Now I will perform all the tasks one by one. Task number 1. Create a new model. Start Mobatec Modeler, and if you go to General Basic Commands tab, here you can find the button to create a new model. You can find the very same button in the top left corner of the toolbar here, or go File, New Model. To resize the model window, go to the corner of the window, press and hold your left mouse click, and just move it to the size that you want. You can do the same if you go to the sides as well. If you want to maximize the window, then just do a double click with your left mouse click to the heading of the window. As we can see, our model is not yet saved. It has a generic name called Untitled 2. To save the model, go to Save As button and choose some other location than Mobatec Modeler folder in Program Files directory. So I'll choose Desktop and save the model with my model name. Note that the basic level of your model is called Universe. This is a generic software given name. If you want to change it, do a right mouse click on the heading and you can choose Rename. Also, if you do a left mouse click on the heading, Physical Topology tab will automatically open, and here you can see that the name of the basic level is Universe. Here you can change it to a first level. Make sure that you don't have empty spaces when giving names with tool words. So if you do this, you will get illegal characters notification. So always use some character in between and click Rename. Of course, you don't have to change the name of the basic level of your model. This was just a demonstration how to do it. By the end of this course, you will learn that you can make multi-level models in Mobatec Modeler that will work to your advantage when creating more complex models. Task number 2. Inserting systems and connections from the library. Go to Insert Objects and go to Systems from the library. Here at the bottom, you can see which library you're using at the moment. What we want is to change the library. Go down and we change the library to a closed circulating flow loop library. Press OK. This library contains all the unit models that we need in order to make the model. So if we check the directories of the library, first we have boundaries, mix and split points. We have heat source, we have liquid sink, liquid source, and mix split point. Indicators and switches, a pump, and two types of vessels, atmospheric vessel and pressurized vessel. Let's now insert all the needed unit models. We need 2 vertical atmospheric vessels, so let's place one here. And if you want to add more, just keep clicking. Let's move this here and place the second one here. And then if you don't want to add any more of these units, you can just press Escape button on your keyboard or right mouse click on your mouse. Once you exit adding library models, the property browser will show the last used tab. In order to access the library again without having to search for it in the property browser, you can use a shortcut, and that is to press S letter button on your keyboard, and you will access your library. Let's add all the other model parts. So add one close pressurized vessel somewhere here. Select pump and select pump model to add a pump. So just keep adding model parts. Then go to boundaries, mix and split points, and choose liquid source. Add it somewhere here. We need one liquid sink somewhere here. And we need some pipe joints. So one here. Let's put one here, one somewhere here, then one we have here, one here, and one more somewhere here. So take a look at the picture, figure 2 in the exercise. Once you're done adding, just press right mouse click or press Escape button on your keyboard to exit the library. Task number 3, reconnecting model parts, building the process. Now let's reconnect all the model parts. In order to reconnect the loose end of the connection, you can just select the loose end, go right click and choose reconnect. And now you can just click and connect the connection. You can now choose graphics and change number of points to 3 if you like to have 3 points, 3 bending points, and make it like this. To reconnect the connection, you can also select the active point of the connection and go right click, and here you can choose whether you want to reconnect the origin or the target. In this case, we want to reconnect the target. And we will connect it to the same point. Now we select the active point and just press 3 on our keyboard to get 3 bending points. We can also move active point of the connection together with the display. So you can see that this point was hidden. I can now return the display where it was. We can also select active point of the connection, do right mouse click, choose set graphical connection offsets, and then change the position of the connection of the line. Select another active point of another line without exiting this graphical connection offset, and select and change the connection of the second line. Go right click to exit, and now just move the bending points the way you like it. So now we have 2 nicely visible inlets to a tank. What you can also do to reconnect the loose end of the connection is to do a double click with your left mouse click on the loose end and then just reconnect it to an object. Let's do the same for the pump connections. Here and this one. Now we have reconnected all the loose end connections. We have to use the library connection models to finish connecting the process. In order to do that, go to Insert Objects and choose Connections from Library subdirectory. Here you will see 3 types of connections: liquid line no valve from liquid to liquid, liquid line with valve from liquid to liquid, and liquid line with valve from liquid to atmosphere to atmospheric pressure. Use liquid line with valve from liquid to atmosphere connection to connect the liquid sink to a pipe joint. Then use liquid line no valve to connect these two pipe joints and these two, and from the tank to this pipe joint. If you exit the connection library, you can access it easily again just by pressing C letter button on your keyboard. So press C and the library will appear again. C standing for connections. Just to repeat, as we already said, if you want to access the systems library, just press S and you will access the systems library. If you want to access the connections library, just press C. Let's finish reconnecting this process. Choose liquid line with valve to reconnect other parts. We have connection here. So use the techniques that we already explained in the previous exercise to reconnect and make alignments the way you want to this model. As you can see, it is very easy to make adjustments. No valve is also here as well. And we have a connection from here to somewhere here. Okay. Let's select active point, press number 3 to get 3 connections, 3 bending points, sorry. We can move this the way we want. And again, let's this one from here, we have a connection here. Also move this one and select it, active point, press number 3 to get 3 points. You can move it a bit closer. Okay. We have a connection here. Press 3 to get 3 points again. This object is actually a text object, which we use just to make this place look prettier. More, we have a connection from here to somewhere here. Also select the active point, press 3, as we need at least 3 bending points to get to this shape. So if we check now, we have one more connection again, and that is connecting the bottom of the upper tank to the lower tank, and also move this here, select to make 3 points, and as we didn't move this display, move this display as well. Now we have connected all the connections of this model. We can now also rearrange a bit more to make it look even prettier. So just get nice alignments. Move this here. We can choose to change this connection point a bit lower, like this, and to move this one a bit like this. Okay, now it's looking nice. Let's continue. Task number 4, adding species to your model. In order to add species to your model, go to General and choose Plant Species and Reactions subdirectory. You can get the same tab by pressing this button in the toolbar. Here, in the Plant Species box, we can see that air is already present. Air is present because it was a part of the closed pressurized vessel model that we took from the library. Now we will add water, as we will use water as a liquid in this model. So press Define Plant Species, and in this tab, at the very top, you have Selected Database. You can see the name of your model, and the database species air, as only air is present in the model. If you press, this is a drop-down menu, if you press this drop-down menu, you will also get to choose Default Database. If you choose Default Database, you will get all the species available within your database, which is installed with the software. So now we will just type here in the filter H2O, or you can just type water, so it will work both ways, and add. Once we see it here, plant species, so we have added water, press OK. Now we can see that we have air and water added to our model database. Now let's add the water to the model. Select liquid source battery limit, go to System Species Topology, and press Set Injected Species button. Select water and add water. Okay. Now we can see that water is present in the liquid source battery limit. These 3 stars signify that water is injected to this system. As a liquid source battery limit is connected with mass connection to the tank, and then tank is connected with mass connections to the rest of the model, water will propagate throughout the model. That would happen in reality as well. So if we select this connection, go to Connection Species Topology, we will see that water is present. If we select tank, we will see that water is present. We select the pipe joint, we will see that water is present. If we select the sink, we will see that water is present, so water propagated in all connected systems. Let's continue. Task number 5, adding flow displays to the process streams. Displays are not necessary part of the model. They are used to display the current calculated value of the variable or parameter, so that we can change parameters value interactively. To add a display, go to Insert, Objects, and choose Value Objects. And just click on the working surface, and you will add a display. Right mouse click to stop adding displays, or press Cancel here. You can also use the shortcut, and that is V letter on your keyboard, to add a display. So right mouse click to exit. We want to make a mass flow display and attach it to inlet mass connection. So select the display, and the Properties tab of the display will open. In the very top we have display type, which says value display. This is the default choice, but you can also choose filled rectangle display. We will talk about this display in the next tutorial. So choose value display. In the description box, type the text that you want to be displayed in the display next to the value of the variable or parameter that you will attach to this display. So in our case, it's going to be fm equals simulation variable. In this box, make sure to type exact name of the simulation variable or a parameter that you want to display. So in our case, it's fm. Linked object. Here is where we are linking the display to a certain object. Just press select, and now you can type the object name, or better and easier way is just to select the object on the working surface. Select the connection. Now we have only that object in the available objects. Press OK, and the display is now linked to this model object, to this connection. Leave reference segment to be 0. We will explain this function in some other tutorial. Engineering unit string. Here we have to type the unit, the dimension of our variable. As we want to display the mass flow, we'll type kilogram per minute, let's say. As you could note, the display value multiplication factor was automatically filled with number 60. This happened because auto update factors box was checked. This is the default choice, and I strongly recommend you to have this checked all the time so that you always get your dimensions straight. Mobatec model uses basic system units, so for the mass flow it would be kilogram per second. As we typed kilogram per minute, then the multiplication factor is automatically set to be 60, which is correct. Number of decimals 2, display value offset 0, maximum value let's set 10, minimum value 0. Then we have a checkbox for allow value access in simulation environment. If you are making a parameter display and you want to use that display to change the parameter value, then check this box. If you are going to make a variable display, as we are going to do now, then leave it unchecked. Then we can change the color of the display. Let's choose yellow, and the default will stay to be black. Once you're done with this size and color settings, press apply. Once you press apply, you will see that the maximum value which we allow the display to display is displayed. And here we have the units, and here we have the description. Once we compile the model and enter the simulation environment, here instead of the maximum value, the real value, calculated value, will be displayed. Now you can align display the way that you like this for example. If you want to add more mass flow displays to other connections in the model, you can reuse this display. Just select the display, go Ctrl C and Ctrl V on your keyboard, or you can also do a right mouse click, go copy and then paste. Select the display and you will notice the green circle around the active point of the inlet connection, which indicates that this display is linked to this connection. So we want to link the display to this connection. Go to linked object, select, just select the connection that you want to connect the display to and press OK, and then press apply. So now if we select this display, we will see that the linked object is this connection. What you could also do is to add a new display by pressing V on your keyboard, place it, let's say here, and then right mouse click to exit, and then copy the attributes of this display, which we already have defined, to the new display. Just select the defined display, press Shift on your keyboard, hold it and press V, like capital V, and then select the new display and just press V. We will see that the attributes are copied. Again, we just have to link the display to the correct model object. the same procedure and press apply. Now add the displays to all the mask connections that you want. Now we have added mask flow displays to all connections of the model. Let's now give the names to our tanks. Select the tank, go right click and go rename, or just select it and press F2 on your keyboard. Give this pressurized vessel the name B103. Rename. This one will be B102 and this one will be B103. Rename. Close. We can see here these three axes, and this is what this is just a text object, and if you select it you will get the properties window of the text object. Here we can see the triple X that we can see on the working surface as well, so you can change that and give it B103, go change text and apply. Now you can see that B103 is displayed on this text object. This B103 is not connected in any way to the tank model. It is just a separate text object which is placed close to this tank object and indicates for the user that this tank is B103. If you want, you can also give the name, indicate the name of this tank on itself, and you just have to select the tank to do that and press 7 on your keyboard to place the name below the icon of the object, or 8 on the top, or 9 in the middle. So you can do that as well, and you can also hide the name by pressing 6. So let's give the name. Let's mark this place with the name of the tank which is next to the displays. So here is B102, change text, apply, and this one is B101. Change the text and press apply. Okay, let's continue. Task number 6, initializing the systems. When you want to perform a dynamic simulation run of your model, you need a certain start condition, the so-called initial values, for all defined variables in your model. In order for the solver to find a correct solution, you need to provide a consistent set of initial values. We will now initialize tank B102 and B101, as all other model parts were initialized already when we took them from the library. Select the tank B102 and go to Equations tab. Here you can see the equations of this atmospheric vessel model. In the upper part, divided with the dotted line, you can see the differential equations, so the mass balance, molar mass balance, and enthalpy balance, which is energy balance. Below, you can see all the algebraic equations, which are called constitutive equations, which are defining the relationship of the variables inside of the model. Next to Equations tab, we have a green check mark indicating that the equations are well posed and that system is solvable. We have red X at Parameters tab, as we haven't entered the parameters values, and we have red X at the Initial Values tab, as we haven't given the initial values and initialized this system. Also here we have exclamation mark in red, which says uninitialized parameters plus uninitialized variables, gives the very same message that we can see here as well. So this is the way to track if our system is well posed, that we have given the parameter values and initial values. Select Parameters tab and enter the values from the exercise here. So use these values and enter them in the parameters tab here. You will see that the check mark next to the parameters is now turned green. If you go to equations, you'll see that you still have exclamation mark in red, but there is only one message saying uninitialized variables. So select Initial Values tab and let's initialize this system. So how many initial conditions do you need? In principle, you need the same number of initial conditions as the number of your differential variables. So if you select Equations, here you can see that you have two differential variables. One is the number of moles of water, and the second is the enthalpy. So essentially, you could define these two values, and you will be able to initialize the system. However, it is very unlikely that you will know to guess correctly the enthalpy or the number of moles. What you can do in Mobatec Modeler is to use the initial condition of some algebraic variables that will be used to calculate the values of your differential variables. So, for example, for the enthalpy, we can define temperature, and we can say that the temperature is 20 degrees. And for the mass of the system, we could define the level inside of the tank, which is much easier to know. Let's say 0.62 meters. The last thing that we have to tell the software is whether this is 100% water, so type 100 here. In order to tell the software that these are the initial conditions, we have to select E checkbox next to the algebraic variable. So at the time 0, these are our initial conditions. The initialization is a two-step process. First, the solver will use these values to calculate the values of the differential variables, and then it will use those calculated values of differential variables to calculate all the values of the algebraic variables, keeping the initial values the same. And that is how we get a consistent set of initial conditions. So just now press Calculate Initial Values. And now our system is initialized, and we can see that the check mark is green, turned green, next to the Initial Value tab. And if we select the Equations tab, now we will see the green check mark and the message that equations and variables are okay. Now we should do the exact same procedure for the tank B101. What we can do is to copy parameters from this tank, as we want to have the same conditions. So go right click on the tank, go copy, and these are all the things that you can copy. But now we want to copy parameter values, and select here, do right mouse click, and go paste parameter values P. If you now go here, we will see that the check mark will turn green and that we have pasted successfully the parameters of the tank B102 to tank B101. We can also copy the variable values from the tank B102. Select right click, go copy paste, and choose copy variable values. Go select B101, right click, copy paste, paste variable values. And now select initial values. We will see that the check mark turned green and that we have pasted the exact values from the tank B102. You can also change the units here. Don't worry, once you're copying the values of the parameters or variables from one unit to another unit, which have different units selected here, the units will always remain consistent, as you can see. The only thing you have to make sure to do is to define the units, but that is when you're making your models from the scratch and defining your equations and your variables and parameters, and we will learn about that in the next exercise. The shortcut to copy a system parameters or variables is to select the origin system, hold Shift and press P if you want to copy parameters, then select the target system and just press P. on your keyboard. If you want to copy variable values, then select the origin system, press Shift and hold it and press V, and then select the target system and just press V on your keyboard. Before we continue, we have to do one more thing related to the model systems. We have to define the water content in all the other model systems. Since we took them from the library, they came without any species attached to them, so they don't have this information. Select liquid source battery limit, go to parameters, and here you can change to percentage and enter 100% water. We have to do that in all the pipe joint elements, so select one, go to initial values. Here water content is variable, so here type 100% water and go calculate initial values. Now you can copy these values from one pipe joint element to another. Just go copy, copy, variable values, select different one and go paste variable values. You can also use V button on your keyboard as a shortcut, and you can keep using it multiple times until you copy something else. We have to do the same for the pump, suction and discharge systems. Pump model is a multi-level model. We will talk about these models in some of the next tutorials. For now, just do a right mouse click and go refine zoom in, or you can just do a left double click on the pipe icon like this. Now we are inside of the pump model on the basic level, and we can see pump suction system and pump discharge system. Pump itself is modeled as mass connection. Select the suction system and go to initial values tab and enter 100% water. Calculate initial values. Do the same for the discharge system. 100% initialize. To go up, you can just select the right mouse click and go hierarchy level up, or just do a double left mouse click on the blue line, or use your up arrow button on the keyboard. So we are back. Let's continue. Task number 7. Initializing connections. Once all systems in your model are initialized, initializing connections is a trivial task. All the parameters in your connections are already entered, as you took the library connection models. The only parameter which you have to change is the elevation of each connection. Use figure 9 values for each connection and enter those values in the model. For example, if we zoom in, we will see that the tank B102 is from here to here 1 meter higher than tank B101. So let's go to the model, select that line, go to parameters and enter -1 meter. Now we can go to initial values and just press calculate initial values. Mass flow is 0, as if we go to parameters we will see that our ZV parameter, which is valve opening position, is 0. We change that to %. Because this is 0, we have 0 flow. For now we will leave it to be 0, and once we compile the model we will open the valves and play with the model. Use figure 9 to enter the correct elevations for each mass connection in the model and initialize each mass connection. Let's continue. Task number 8, the last task of this exercise, running a real-time dynamic simulation in Mobatec Modeler. Once that all model parts are initialized, you can compile and run the model. Go to Basic Commands tab and press Compile and Go to Simulation button. You can find the very same button here in the toolbar. The model is now compiled. In Basic Commands tab, set Dynamic Simulation Type, Fixed Step Size Integration Method, Step Size of 1 second, and Calculation Delay of 1000 milliseconds. We have calculation delay of 1000 milliseconds because our calculation step is 1 second, which is 1000 milliseconds, and like this we will be able to run the simulation in real time. Now press Start Calculations. As you can see in your simulation time, these are real seconds, real time. You can also follow the simulation in your left bottom corner here. Now let's play with the model a bit. Let's fill the upper tank from the lower tank using a pump. First, let's open some valves to make sure that the pipes are open. And now let's start the pump. Here we can see that flow is happening. This is real time. And the level in the lower tank is dropping, while the level in the upper tank is rising. You can open some bypass valve to reduce that effect. Open this one as well. Let's open this one as well. And now you can follow the flows, which are pressure driven and determined by the elevation difference. Now we can pause the calculation. Now let's make this model even more interesting and add a heat source, some level alarms, and some more indicators. Go to Modeling Environment by pressing the Mod button in the toolbar here. Go to Insert Objects, Systems from the library, and choose Heat Source. Let's move this here. Place it here. Right mouse click. Double click on the loose end of the connection and reconnect. We have added the heat source. Okay. We can now adjust a bit the displays to look prettier. Let's add some indicators. High level switch here. Let's put it here. And let's add some low level switch. Let's put it here. Let's add some pressure indicator, for example, here. And let's add some temperature indicator, let's say here. You can also add some level indicator, for example, here. Right mouse click to exit the library. Let's now reconnect these newly added model parts. So double click on the loose end of the connection, like this. Okay, here we need one bending point. It was 0. Good. Let's connect the low alarm and high alarm, and also the level indicator as well. Now let's recompile the model. But before we do that, we have to initialize the indicators that we have added. So select all of them. Just hold the Control button on your keyboard and make multiple selection. And go and click this button, Calculate Initial Values of Selected Objects. Okay. Now go to Compile and go to Simulation button. Press Yes. We want to discard the previous model. Okay, the model is now compiled. We can observe immediately that our pressure, temperature, and level indicators are working. Now let's start the calculations. You can follow the simulation time here, so it is real-time simulation. And now let's turn on the heat source. Now we should observe the temperature rise up to 30 degrees, what is the set temperature for the heater. You can change this interactively as well. If you go 40, then the temperature will rise up to 40 degrees. Now let's check whether our low level alarm is working. Let's drain the tank B101. Let's open this valve, the sink valve, and now we have the flow. This is going a bit slow, so we are going to stop the simulation and delay the delay and start the simulation again. Now it's going much faster, but you can also do this while the simulation is running. So you can change the delay dynamically. And we'll see that it's 0.15, I think, meters. We'll now stop the calculations. The low level alarm goes on. Now you can play with the model, change elevation settings of your connections and see how that affects the model. One more thing that you can do to make your model look nice is to draw one connection behind other connections. To do this, go to Modeling Environment by clicking Mod button in the toolbar. Select the connection that you want to draw behind. Go to Graphics tab of that connection, choose Attributes subtab, and check Draw Behind Other Connections. Make sure to press Apply. Now you can see that this connection is behind the connection that passes over here. You can also use the shortcut on your keyboard, which is letter B. Just press B, select the connection before, press B, and you will see that this connection now is behind other connections. To go back to simulation, just press Sim button in the toolbar, and now you can see that you have the same settings in the simulation environment. You don't have to recompile the model in order to use these settings, as this is only related to the model graphics. If you make changes to model equations or parameter values, and you want that changes to take effect, then you have to recompile the model. The same applies to displays. You can make changes to display settings and just go back to simulation environment and keep running the simulation. This was all for the second exercise of Mobatec Modeler Introduction course. Until the next help video, stay dynamic. Bye.